with the next lesson in Chapter 2. We're actually going to be doing 2 lessons today because they both follow the same exact rules. So in 2.4 and 2.5, we'll be talking about multiplying and dividing integers. So if we look at this first screen here, this is kind of a little cheat sheet for you. If it helps, when you get a paper, just draw this quick tic-tac-toe board, positive signs put on the middle, and then we fill everything else in with negatives. So what this tells us is if you read across or read down, a positive times a negative equals a negative. A negative times a positive equals a negative. Then a negative times a negative equals a positive. And then if we go diagonal, positive times positive also equals positive. Now these are the same rules for division. So I know I said times for multiplication, but same rules for division. And over here, if your signs are the same, so positive times positive or negative times negative, we get a positive solution. If our signs are different, so positive times negative or negative times positive, we get a negative. Let me get this pen size fixed for us. Okay, so now that we know our rules, let's look at some practice. So off to the side here, this is on the same screen for you guys, but off to the side, I'm just going to draw a quick tic-tac-toe board. So positive, 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 negative, 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 negative. See how quick that was? So when you get a paper, you can do that real fast. All right, example number 1, negative 2 times 8. Well, we know that 2 times 8, if we ignore the signs from the beginning, is 16. So now I want to look at signs. I have a negative times a positive. So we go over here. Negative, positive gives us a negative. So negative 16. Number 2, negative 4 times negative 4. Well, I know that 4 times 4 is 16. Negative, negative. Check out our board. Negative, negative gives us a positive. So our answer is just 16. Number 3, 6 times negative 2. Well, we know 6 times 2 is 12. Positive, negative, different signs. So negative 12. And the last one, negative 7 times negative 3. Well, we know 7 times 3 is 21. Same signs for positive, so our answer is 21. All right, same idea, simplifying expressions. So now we are involving our variables, but we're following those same rules. So negative 2 times 3, we're going to multiply our coefficients, multiply the numbers. Negative 2 times 3 gives us a negative 6, opposite signs. And I have 1x, so it's negative 6x. Just like in chapter 1, we want to look at what can we do and then bring the variables along. 26 here, we have negative 4 times 5y. Well, negative 4 times 5, different signs, so negative. 4 times 5 is 20. And we bring the y along. All right, for number 27, again, same idea. 9 times negative 2z. Look at our numbers. Opposite sign, so it's negative, and then 9 times 2 is 18. Bring along the z. And the last one like this. Negative 5 times negative 6a. Again, I underlined those numbers because those are what we're working with. Same signs, so positive. 5 times 6 is 30. A. All right, if we look at 47, we have one example like this. Evaluate the expression of x equals negative 5 and y equals negative 6. We know our first step is to rewrite the problem. Second step is to substitute. Make sure we are practicing writing out all these steps. I'm going to put these in parentheses. So 6 times negative 5 times negative 6. We definitely want to use parentheses around here so we don't accidentally think it's negative 6 minus 5 minus 6. Okay, so negative times a negative is a positive. Positive times a negative is a negative. So we know our answer is negative. And then 6 times 5 is 30. 30 times 6 is 360. If you needed to do that in more than one step, you absolutely may, or you can multiply them all three at the same time. Both ways are perfectly fine. So our answer is negative 360. Right now at the bottom of our page, let's do a little practice with division. So we're going to divide divide like normal, keeping in mind our sign rules. And just like I said on the last screen, the sign rules for division are the same as for multiplying. So 16 divided by 4. We know that's just 4. We've been doing that for years. Number 2, negative 27 divided by 3. Well, I know if I ignore the negative, 27 divided by 3 is 9. Negative, positive, you need to go back to your board. Negative, positive gives us negative. Oh boy. Okay, looks like we can keep going. Number 3, 25 divided by negative 5. Well, 25 divided by 5 is 5. Now check our signs, positive, negative, go back to our board. Positive, negative gives us negative. And 63 divided by negative 9. I know 63 divided by 9 is 7. Different signs, so negative. All right, there's some practice working with our sign rules, working with evaluating, showing all of our steps again, and simplifying. A little bit of review from chapter 1 there. All right, last up, we have a couple of problems here. Another evaluating problem. Evaluate each expression if x equals negative 8 and y equals negative 12. So again, we rewrite the problem. Negative 144 divided by y. We show our substitution. It's negative 144 divided by negative 12. Okay, same sign, so we know our answer is positive. 144 divided by 12 is 12, so our answer is 12. Your last question, nice word problem for you. Determine whether the following statement is true or false. If false, give a counterexample. Okay, so we want to decide if it's true or false. If it's false, we need to give a counterexample. If you need a little vocab review, remember that counterexample meant an example that proves that it's false. If it's true, we still want to give an example. All right, our statement is, division of integers is commutative. Well, we know from last chapter, commutative meant that they could move, or we're talking about the order. So division of integers is commutative. Now we can pick any integers. So let's say we're doing 12 divided by 4. We know that we can do that. We want to decide, is this equal to 4 divided by 12? Well, 12 divided by 4 is 3. Now if we try this, watch your order when we're dividing, guys. You have to make sure you're putting the right number in the calculator first. 4 divided by 12 is actually 0.33 repeating, or 1/3. So now we need to check, does 3 equal 1/3? It does not. So here is our counterexample. So 12 divided by 4 does not equal 4 divided by 12, so it is false. You could have used any numbers there, as long as they are different numbers. You could do 4 divided by 4 because that's 1 either way. All right, guys, there is your lesson for sections 4 and 5.